Hello everyone, welcome to Naurusa's CSC tutorial. Hope you're all doing well. So today I'm starting with lattice. Lattice is a very interesting and important topic of hash diagram and POSET. So starting with the definition of lattice. So what is lattice? Let L be a non-empty set and conjunction and disjunction are two binary operations defined on L. L is called a lattice with respect to these two operations if the following axioms hold. So this is the first property to be a lattice. For all AB in L, A conjunction B belong to L and A disjunction B also belong to L. And these two properties are called closure property. And now the second property, for all AB in L, A conjunction B is equal to B conjunction A and A disjunction B is equal to B disjunction A. And these two properties are called commutative property. So this is the second property to be a lattice. Now the third one is associative property. A conjunction B conjunction C is equal to A conjunction B conjunction C, and A disjunction B disjunction C is equal to A disjunction B disjunction C. These two properties are called associative property, and this is the third condition to be a lattice. Then the last one, or the fourth one, that is absorption law, and that is A conjunction A disjunction B is equal to A and A disjunction A conjunction B is equal to A, and both these properties are called absorption law. So this is the last condition to be a lattice. So hope the four conditions have hope all the four conditions are clear to you. And now I am sharing some of the properties of lattice. These properties are very important to understand lattice. So the first one is idempotent law, and that is under theorem 1. In a lattice L, conjunction disjunction for all A in L, A conjunction A is equal to A and A disjunction A is equal to A, and this is called idempotent law, and this is the first property or the first theorem of lattice. And this is theorem 2. In a lattice L, conjunction and disjunction property, these two property holds, like A conjunction B is equal to A if and only if A disjunction B is equal to B. Theorem 3 is a POSET is a lattice if the supremum and infimum of AB exist for every pair of element AB in the set. So this is the theorem 3 of properties of lattice. And now the theorem 4. A lattice is a POSET in which supremum and infimum of the set AB exist for every pair of elements in the set. And this is theorem 4. Now theorem 5. Every linearly ordered set is a lattice. Now the last theorem, or the theorem 6 of lattice, let L conjunction disjunction be a lattice and M is a subset of L. M is sublattice of L if and only if for all AB in M, the first condition A conjunction B belong to M and also A disjunction B belong to M. So this is the last theorem or the last property of lattice.